Hello, my friends, and welcome to another one of Miss Claire's instructional videos. Today we are going to be talking about combining like terms, but in order to talk about combining like terms, we need to talk about the parts of an expression. So the first part of an expression we're going to be talking about is a constant. Constant means doesn't change. Any term that has a variable in it, that's going to change. It's going to vary. So the constant terms in here are 12. That only has a numerical value. That is our constant. The variable, we talked about that last instructional video, last lesson. Variable is x. That is the value that denotes an unknown numerical value. The coefficient is the piece that multiplies the variable that comes in front of it. So in here, that is 4. Co meaning it goes along with. So it goes along with the variable. And the terms are the pieces of the expression that are separated by addition or subtraction. So in this case, we have subtraction. So our terms are 4x and 12. 4x and 12. So what does a coefficient really mean? Well, a coefficient tells us how many of something we have. In this case, it's telling us that we have 4 x's. In this case, our 3 is telling us that we have 3 4s. We can simplify this one all the way down to 12. In this case, we have 3 x's, or 3 times the quantity x. So that means that we have x plus x plus x, or 3 x's. Here, if I just have a single x, is there a coefficient? Well, coefficients tell us how much of something we have. How many x's do we have here? We have 1x. So our coefficient is 1. It's hidden. We don't need to write it there. But it is important to know that we have 1x there. So let's talk about combining the terms and terms that are alike. Up here, we could combine all of these terms because they are like terms, and we can combine them to have a coefficient. All of these are numbers, so they are like terms. We can combine them to have a coefficient of 3 because there's 3 of them. Here, they have a coefficient of 3 because we have 3 x's. We could combine these. In this case, if I have 2 and 3, can I combine those? Can I add or subtract those together? They're just numbers. Yes, I can. Those are like terms. If I have 3x and 2x, this is telling me an amount of x's that I have. So that unit there is the same, meaning they are like terms. They're both x's. I can combine them. Yes. Whoa. Got squiggly there. In this case, I have 3x and 3y. So the terms that I have here are in terms of x's and y's. Those aren't the same unit. I can't add an x to a y, combine that, because I don't know what those values are, and they're two different values. So no, they are not like terms. Same here with 3x and 3x squared. Since I don't know what x is, I don't know what x squared is. I cannot add those together to find what that is. So no, they are not like terms. This is where it gets a little tricky. If I have 3xy, that means I have something in terms of xy, or I have 3 xy's. And here I have 2 yx's. What this really means is 3 times x times y, and this means 2 times y times x. Multiplication is what we call commutative, so we can swap things around. So we can also write this as 2xy. That is equivalent to 2yx. So 3xy and 2xy, these are equivalent things. These are equivalent terms. Yes, they can be combined. We can also think about it as 3yx and 2yx. We can swap either of them around. We just usually like to go in alphabetical order. Put my little and symbols between there. So let's practice some combining like terms. If I want to simplify each of these expressions, here I have 3p's plus 2p's. If I want to write that out really longhand, I can write out that's p plus p plus p. That's my 3p's plus p plus p. So how many p's do I have there? 1, 2, 3, 4, 5. That would be 5 p's. That's my simplified answer. It's just one term. That's as simple as it can get. So what are the variables? The variable here is p. The constant, I don't have any just numerical term. So the constant is 0. You're always adding a 0 on at the end of something, right? I could also write this as 5p plus 0. That would just be unnecessary. How many terms are there? There's just one. And what are the coefficients? The coefficient, or the thing multiplying the variable, is 5. If I want to simplify this next one, I have 5p plus 3n minus 2n plus 6. I can do some swapping around because I want to be able to combine like terms. I'm going to use some different colors here. I'll use blue for the p's. Here I have 5p and 6p. Those are like terms because they're both in terms of p. My 3n and 2n are also my like terms because those are both in terms of n. So I can do some swapping around. Since this is all just addition and subtraction, I can put the 6p over here and keep in the addition with the addition, so 5p plus 6p. And then I'll swap back to my other color. I have plus 3n minus 2n. So now it's a little bit more clear about how I can combine these like terms. I have 5p's and I have 6p's. Well, just as we did over here, we can find that 5p's plus 6p's is going to give me 11p's because I have 5 of something plus 6 of something. For the n's, I have 3 n's and I am subtracting out 2 of them. So 3 minus 2 gives us 1, so that is plus 1n. But as we set up there, we don't really need to write the 1. We can also just write it as n. So if I want to write this all out in one color, I could just say that this is 11p plus n. So what are the variables? The variables here are p and n. It's my little and symbol. I'm not sure if that's the most common and symbol anymore, but it's the one that I like to use. What are the constants? The constants, the things that are multiplying our variables, are 11 and that invisible 1, or the 1 up here and the 11 up here. So 11, oh, not the constants. There's no constants here. It's talking about the coefficients. I was jumping the gun. I was wanting to talk about coefficients. So there's no just numerical term. So again, the constant is 0. How many terms are there? There is 2 terms. This is 1 term. This is the second term. Our coefficients, like I just said, are 11 and 1. Those are the things that are multiplying our variables. Lastly, for this video, we want to simplify 3 times the quantity x plus 4. So this coefficient here, what that means is I have x plus 4 plus x plus 4. I need to hold my laptop more steady. Plus x plus 4. So I have all of that 3 times, right? So let's do some highlighting. Let's do some underlining. The like terms here, we have our x's and our numbers. So our x's, I meant to write plus between there. Just forgot. So my x's are my like terms. I can rearrange this, again, since it's just addition. I'm keeping the addition with the addition. And I want to keep the like terms with themselves. So I have x plus x plus x. And then my other like terms that I can combine are 4, 4, 4. Those are all numbers. I can combine all those numbers. So plus 4, plus 4, plus 4. So what that means is I end up having 1, 2, 3 x's and 4 3 times. which is just 12. So in the end, I end up with 3x plus 12. You can also see that if I distribute this, if I distribute that 3 to the x and the 4, I would need to distribute it to all of it, but 3 times x gives us 3x. 3 times 4 gives us 12. So in our fully simplified expression, what are the variables? The variable is just that x. The constant, or the term that is just a number, just a numerical value, is 12. How many terms are there? There's 2 terms. And what are the coefficients? The only thing multiplying the variable is a 3. And with that, I'm going to leave you to simplify this last one on your own, figure out the variables, constants, terms, and coefficients. And once you are done with that, you're going to come show it to myself or Mr. Myers for a treat and or sticker. Don't forget about your vocab terms and your examples for that. And I will see you in the next one. Thanks for watching.